On behalf of Space Education and Research Foundation and on my personal behalf, I am very happy to welcome Professor P.C. Joshi, the speaker for this webinar, Introduction to Meteorology, and all the participants from different countries participating in this webinar. Before I hand over the mic to Professor P.C. Joshi to deliver his today's talk, which is on climate and climate change. This is the third talk in this webinar series, and I will briefly introduce him to you. Professor P.C. Joshi worked for 3 decades at Space Application Center, a unit of ISRO. He developed a strong group for working in the front area of satellite meteorology and its application in tropical weather systems. He was course director of satellite meteorology of CSTP course, which is affiliated to United Nations. He also worked as emeritus professor at CSTAP headquarters in Dehradun. After obtaining his PhD degree in theoretical physics from Banaras Hindu University, he worked as faculty member at BHU and also as a senior scientific officer at Indian Institute of Tropical Meteorology, Pune. He has undergone World Meteorological Organization approved advanced training course at Indian Meteorological Department. He has more than 100 research papers published in standard peer review journals. He has been in the editorial board of reputed national and the international journals related to meteorology. Professor Joshi was very actively involved in popularizing the science of meteorology. In fact, he is even today is popularizing this. His talks in this webinar is also part of his interest in popularizing meteorology world over. And most of the programs that he did before this were used through Indian Meteorological Society, in which he held many important positions at national as well as local levels, different chapters. With these few words, now I invite Professor P.C. Joshi to join the room, and I will leave from this room and listen his talk. Professor Joshi, please.
Thank you, Dr. attending the talk under this webinar series. And today, in the third talk, the topic we have decided is climate and climate change. I understand most of you attending today's talk must be there yesterday also, where we discussed about the science related to meteorology, or particularly weather, but something related to climate also. There, I just started with saying that meteorology is such a multidisciplinary subject that large number of science disciplines are required to understand it and are part of the meteorology. Climate is part of the meteorology, but when we add this climate change to climate, the many things change. Not only climate change, but the scope changes, and the other discipline that is added, which I was discussing yesterday, is politics. And this politics has popularized this, and once the politics comes, climate change has been publicized quite significantly with its pros and cons that we all are aware. Anyway, that was on the lighter side. But we will definitely speak about the climate and climate change, and at the end we will see that some of these unnecessary views and many things said about the climate change will have to be seen in the proper perspective. So the topic is climate and the climate change, and what I am trying to cover in next 45 minutes, something about climate. I have been talking few things about this yesterday and day before yesterday. We talk about a little bit what exactly climate and what is climate variability. And is there any difference between climate variability and climate change? We'll discuss that. And then we'll see that certain causes. They will tell us about the variability and the climate change. What are the causes of this? Very important thing. And that will tell us about the change also. And then because in this we'll come to know that there will be few things which are the civilization is responsible for those causes, and that is where this today's discipline, what I was talking, gets added to that. So we'll discuss something about that and the consequence of all this climate change that is likely to happen. We'll discuss about that. So having said that, we move to the again this climate with the basic definition of the climate. Climate is derived from the weather only. Weather, as we said, is what you get, characteristic of the atmosphere over a short period of time. But climate, when we say the climate means this is the average over a long time, depending on what type of thing you are looking for. And this is what I call climate is what you expect, not what you get. In normal parlance, many times even I have seen many persons, students, scientists talking about that today's climate is not good. This is very common but that is a wrong statement, because we can't have today what is happening outside today. That is weather. You will say about the weather, but what you expect today to happen, that is the climate. So that means the average behavior of the earth, ocean, atmosphere system. That is the climate, and that is what we look for. Okay. Having said that, we move to the just see that was the definition. Just see that what is climate. I have taken here two examples from a work by somebody. There are two cities in India, Mumbai, which is 11 meters above the sea level, very close to the sea, and New Delhi, very far away from the mainland city. And what happens to this? So these are the different parameters listed here. The climate of the Mumbai, climate of the New Delhi. Now this is the temperature, average temperature during different 12 months of the year. So this is, I will call this the climate. Okay. And not only this, I have the maximum temperature and minimum temperature. Those are listed there. From there, this average behavior is obtained. So maximum temperature, climate. Rainfall, this is a very sensitive station for the rainfall. A lot of monsoon rain occurs during the months of the June, July, August. So you can see there's a lot of rain occurring here. And similarly for the humidity and event. So different parameters that will call as the climate of that place. Go back to the other station, Delhi, you will find a lot of change in the temperature. Here, ocean regulates and we don't have much temperature changes. Here you will see that a lot of changes take place in the temperature. Summer, winter and rain is not that high as we have in Mumbai. So this is the climate. So and normally the average period that has been ascribed by the World Meteorological Organization is 30 years. So that 30-year economically, statistically, that comes out to be a stable number. It's not that way. It's a holy number that if it is less than 30, that number doesn't remain stable. And we want a stable number to represent the climate. So roughly 30. So depending on if you have a large number, we are studying to 30 to 100 years. That is what is written here. So that's the climate. Now let us see. I have shown you one or two cities monthly climate. what is happening? See the global annual average rainfall. This is the climate of the globe. Whole world, how does the rainfall occur yearly, average yearly rainfall over the whole year? You can see there are the different, this is a diagram here, yellow color shows up to 250 millimeter and this blue is up to 2000 millimeter and beyond this is more than 2000 millimeter. And we'll see most, as I understand, mostly we are from the Asia Pacific countries. You see the region here. We have the big deserts, yellow region, and Indian part here, and Mumbai and this Western Ghats giving the good rain, and good rain here, and good rain here. And so this is the climate wise, this is the rainfall, and you will realize how did we derive this? This we derive from weather only. Weather of a particular day gets some to the month, then the year wise all data taken and then ultimately we come back. So that's the meaning of the climate. This is the global wind. You average it in the month of January, this is the wind. Yesterday also we had some discussion about this is the observed climate global wind. Wind direction here, wind direction here. And if you concentrate on our region, particularly the Indian region, this is January, the wind direction and surface is all in this direction. That we call as a northeast monsoon. And in the month of the July, you go here, this is the month of the July, and the total, this wind reversal has taken place. This is a great climatic event in our Indian continent or in the Southeast Asian region, that is the southwest monsoon. So the total wind reversal has taken place and that is what gives most of the rain. So this is the wind climate or the globe. This is atmospheric water vapor content in January and July. So again, the atmospheric water vapor content, you will find that over the equators, the maximum this is taken from a book, so some of the number you may not be able to read, the maximum water vapor comes around the tropics because a lot of temperature is there, sea is there, and the water vapor, in fact, these are the hotspots of the water vapor, tropics. Most of the water vapor will be present in the tropics. This is mean evaporation for January and July, a representation of what I said earlier, and mean global precipitation. For the periods, two separate periods. This is the northern winter and this is the June to August, the northern summer. These two regions, and you will find our region here with the heavy rain occurring. I hope this is available. This is the highest rain and this is the lowest rain, less than 0.5 millimeter per day. Millimeter per day is the unit for this. So this is the climate of the total globe I have shown you, and that in that region you can see in that. The pressure, which is the most important parameter for the weather climatic systems to move, weather systems move on the basis of the whatever is the climatology of the, we can assume that this pressure on the basis of the pressure systems, what is expected as the weather movement if something happens around that time, that is how the pressure distribution becomes important. Okay, this is for the sea level pressure difference, the southern, that earlier one was the northern hemisphere, this is the southern hemisphere. So that much part is my first thing about the climate. What do you mean by climate? How do you get it? And what different meteorological parameters have the climate around the globe? Now we come to climate variability. That is the essence of today's talk. Climate variability, again, on the longer time scale, if any parameter is there, that means there can be two types of things. Climate, this is a year to year, month to month, this is changing here. So this is a variability. Depending on what scale we are using, this is a climate variability. Now this variability may be because of natural things, this is inherent in the system and it may be coming in that. So this frequently, normally in the variability, you will find the patterns repeating and they may not be, meteorology and the climate is such, the exact repetition may not be available. That's the nature of the chaotic nature of the science, but things repeat. So the variability, you will find that there are certain variabilities in that. This is the variability. But if there is a change, change means the unidirectional things are happening. This, for example, this straight. This I have shown here as an example. Something is increasing. So a climate change, not climate, something is changing. Change is taking place. Here, this change is on the positive side. It can be, you can put it in a downward side. It can be depending on what it is. And what we see now, actual climate variability plus climate change is the exact thing that you get. So this is what we get. From this we have to infer, and both the things have their own, climate variability has their own causes, climate change have their own causes. And if it is not variability, climate change may have some, may not have some natural causes. That is what we expect, and that is what we are going to discuss. So hope I have made clear what is meant by the change and what is meant by the variability. Climate variability is very predominant in our, for example, this. You will excuse me because we are the Indian meteorologists, we are familiar with most of our Indian data. This is an all India monsoon rainfall, that is from June to September, 4 months average rainfall. And how does it differ from the mean? So this is the climate. This is the, now you can see the variability here. That year to 1873 to 2003, the authors have plotted the rain, and from the long period average, percentage departure. So percentage departures are coming up. Now this is the variability. Somewhere it is positive, somewhere it is negative, somewhere it is very close, somewhere very, very negative. So these are the drought years, in the big droughts, normal droughts, and on the average, similarly very heavy rain and normal rain and some normal. So there are certain characteristics. So this is what the variability is. This I can call, or if this particular rainfall series, if you consider, this will be taken as interannual variability, because every year to year it is giving the diagram, or in fact here this is the 5-year different interannual variability. That means year to year how does it vary. So this is very important. Now that means there is a variability there, and that variability we have to be aware of that, and we have to be concerned about the variability, and then we'll see that how to go about understanding the variability, right? So this is one example. So in this monsoon variability, now this variability will occur. This is, I have shown you one parameter as the rainfall, but there are many other parameters that can be used, and we can find out the variability, and we study it. For example, we can have wind. Not many people have studied the monsoon variability using the wind data for many years. Outgoing long wave radiation, very, very important parameter, which gives us some sort of a representativeness of the convection or the cloudiness prevailing around the latitude, OLR, very important climatic parameter. We can study this. All these variabilities we can get. From these variabilities, then we can go to the cause of this variability, then verify that hypothesis and use that hypothesis in understanding any future things. So this is, so one of the variability is interannual variability. I did show you for the rainfall, similarly for other parameters. But not only interannual variability, there will be certain other type of variability. All these parameters like the rainfall, what I showed you, they show certain other ways. So statistical techniques are used, and they are the great tools available for finding out these oscillations in this data series. So we have the large amount of the data, and the data learning can be done, and with that data we can. So particularly one thing I can show you about the monsoon variability, we have 30 to 60 days, 10 to 15 day oscillation, and of course diurnal variability will be there. So now this is the beauty of the climate. We'll never say 30, we'll never say 60, 30 to 60, because it doesn't occur that way. It always, there is a range always here, because year to year so many things are happening, and decade to decade things are happening. So you will never have a fixed variability. It's not a sinusoidal curve or some curve that exact periodicity will come. No, that doesn't happen. So these variabilities are there, and each variability will have certain range, and then range has to be, and that is the call. Now ultimately what I get, if I have the data, all these variabilities are present in the data set. So it becomes that data set some sort of becomes a little bit of, initially it may appear to be chaotic, depending, of course the climate data is not that chaotic as the weather data, but from that data, total chaotic data, we have to ascertain them, and there are statistical techniques, they are being used, and these variabilities are being studied. In climate variabilities are studied. I may add that whenever we say climate variability, climate change, our mind goes to the temperature only, because that is the one thing that has been advertised globally, and that is also because that is representative also. But when we say variability, it's not only temperature change, but in all other aspects, temperature change is one of the representative. Now, for example, this monsoon variability is a very classical paper in Indian meteorology. This was when no computers were available, no satellite receiving data stations were available. Some photographs from the US satellites were available, and great scientist Sikka, Indian scientist, tropical meteorologist, and Gargill, two great meteorologists, they manually did it for the years. How does the cloud band move from the Indian Ocean northward movement takes place, and these all are part of the 30 to 60 day oscillation, which they did not know at that time what it is, because that time it was simply the cloud band movement they have said. So these oscillations are embedded in the data. So if we are trying to see the rainfall series, temperature series, then every time one has to be aware that you will not get a systematic variability, but you will get all different types of variability. This is a unique example of that. Another variability you can see now, the temperature. That was a small scale, now it's a global temperature. Northern hemisphere temperature changes last 1000 years, 1000 to 2000, they have changed like this. And the deviation there, here it has been taken, because the 1960 to 1990 temperature is a model temperature. From that deviation that has been taken, this is plotted on the y-axis, and you see this. The temperatures were all below that, because this is maybe because of the 60 to 90 is the baseline taken, so these has come here. No problem. But this data, how does this data come? There were no thermometers available here. So these were some calculation that we call as a paleoclimatic data. This is taken from the tree rings. From the tree rings, we can get the past data, we can get the life of the tree ring. From that life, each year it produces one ring, and the width of ring is proportional to the temperature and rainfall around that year. So like that, this data can be created. So we have tree rings, we have sea corals, we have ice cores, historical record, variety of things are there, and this is from where this data is taken, and we have here. And this is the reason now where the thermometer regime has come. What we find, this is a significantly thing happening, straightway going down, and that is what is the climate change type, what I showed you earlier. So if the past 1000 years, if you see this, so this has been very systematically analyzed, this data, then you will find that now something is happening around this time, and the data is now accurate. This data was not that accurate, but they try to get maximum accurate info as far as possible. This is the concern station. This is a global average temperature. So that means that global average temperature around this time is now increasing. That is what is happening there. Okay. So you can summarize this, because this is a wonderful data set available. So you can see that there is no change, hardly any change occurring here. Approximate climate range over the 900, that is a climate range, the data is there. Okay, last century appears unusual, what I said earlier. So that is the concern, that is what is up to the now climate change represented in this chapter. But the climate variations before the industrial revolution were almost certainly natural. What caused them? And could 20th century warming also be a natural variation? So that is what the climatologists, the scientists, they investigate, and a lot of research is going on. A lot of information is also there. So that I'll show you some of the things. Next one. So now we come to the, if we have seen that certain changes are there, definite changes are there, so what causes the change? How to change global climate? Now, there is one thing that we must also distinguish again. There is a global climate that is taken as average as a whole, and there will be regional climate also. The regional climate is different from the global climate. If something is happening globally, average, something on the opposite direction may happen in certain regions. So that is quite likely happening. So that one has to distinguish. The regional climate is altogether a different game that way, though the methods, the data and other things will be similar. But when we talk about the regional climate and the global climate, one has to make that distinction. Now, what we'll be discussing mostly, because in the short period of time we cannot go into too much of detail, we'll be discussing much of the global climate. So the changes for that, what is the recent years happening in that. So what could be the natural causes of climate happening? We did discuss yesterday. The main source of energy for the climate is the sun, sun's energy. The total energy coming from the sun received by the earth system, atmosphere, ocean and earth, and circulation, that causes it. So the main source is the, so anything happening in the sun, energy coming from the sun, that definitely makes change. And it has been still investigated by many astronomers, earlier calculated, and we know that the earth moves around the sun. Precisely the things have been calculated. This orbit which moves around the sun has certain variations, and these variations will cause definitely the input energy to our planet and definitely change the climate. So certain periodicities has been found in that, but those periodicities are long period. Definitely those periodicities will somewhere affect us, but they have the large thousands and millions of years of that data, but that does come into the present day in some minimal form that will come. So we'll discuss about that. How does it change? Then this sun itself, the sun is giving the energy, but the sun itself, there are a lot of variation taking place in the sun. So that variable energy solar output, because of the sun itself. The earlier one was because of the orbit of the earth, second is because of the sun itself. So the sun itself, there are many activities, there are certain spells when many things happen within the core of the sun, so it emits more radiation and that will change the climate. It has some periodicity. So that those are few things coming up. Changes in ocean circulation pattern. Ocean is one of the great regulator of the climate, and that any changes happening there, that will definitely change the climate. Now this is some sort of different feedback. Ocean circulation, how can you change? Ocean circulation can be changed because of certain inputs to the ocean. But ocean is ocean. It is so much of this. But if a delta X can be added to X, it won't make much difference. If you can increase the delta X, then definitely certain things will happen. And ocean is one of the regulators of the climate, and that can also change it. But when that may come under the natural, that may not come in the natural. The certain things which are happening naturally may also change the ocean circulation, but our own concern, man-made concern, can also change the circulation to that area. Albedo effects, the total land surface, the sun radiation coming, getting totally reflected, getting less reflected, it gives a lot of information, and that also can cause. And greenhouse effect, that is the most concerned, and that is how the things can change, whether we are disturbing the system, which we call. So one by one we will see this and then see what is there. So I have already said this is what is about the orbits. This is Sun, Earth moving around the Sun. Now these orbits make changes. There are three types of change. This is called a Milankovitch cycle. Milankovitch cycle is the Earth's eccentricity of this ellipse can change, and roughly I just it can change from 0 to 5%. It has been observed, and 0 to 5% ellipticity change will take a lot of energy input change, and that can cause. So these are some periodic system. So periodicity will be there, so variability will be there. The Earth axis can tilt of the Earth axis. At the moment it is 23.5 degrees to the normal. This 23.5 degrees is also not fixed. That also goes on changing because of the so many effects happening in the cosmos. It goes from 21.5 degree to 24.5 degree. At the moment today it is at 23.5 degree. So that will also change. So this will also give you periodicity. And third thing is when the Earth is precessing, this precision also changes. Precision is because this is like a top, and this precision is basically wobbling of the Earth also causes certain periodicity, and the wobbling itself will give certain period. So these three periods are natural causes, but a long scale. What is the scale? See this Milankovitch cycles did not go. Today it is 23.5 degree. The tilt 11,000 years ago it was here, and it gives a 41,000 years cycle. So 41,000 years we are not going to see, you, me, anybody will not see. But does that effect definitely will come. So whenever the old ice ages and other things we discuss, we go to these things and then discuss what the climate change. Definitely that effect somewhere beyond today, somewhere 41,000 will come, and that is how it will. So the small time climatic variability, if you are looking for, they will not appear directly that way. So we'll have to see something else for that. So that was ellipticity of the Earth. It's 90,000 to 100,000 years. The ellipticity and circular one, I said that the 0 to 5% ellipticity changes, it can produce that. So this is a Milankovitch, three cycles in the Milankovitch. Third with the precision. The Earth moves around the Sun, and the precision of the Earth gives us the periodicity of the 19,000 to, oh I'm sorry, in this slide there is one extra zero that has appeared. This is 19,000 to 23,000 years. Even these calculations are to that extent the periodicity has been not fixed, so that is what we get the periodicity in that. One interesting thing that we could find here, at the present place where we are living, the northern winter, Sun is nearest when it is winter. So that is the way somebody will get surprised that the Sun is in this orbit. The Sun distance is the nearest to the Earth when it is winter. Normally you would expect that if it is summer, so it should be coming summer. No. And this goes on, this is what I said, this goes on changing. Sometime it may come in the summer also. And around the present time, this is the time that this is coming as the, okay. So this is Milankovitch cycle, large, big periodicity, come in a minimal way in the present chaotic nature. This is the ocean that I was saying. Ocean has a large ocean conveyor belt, this is called. Global ocean conveyor belt. What happens is the equator receives a lot of energy, poles receive very less energy, global ocean get heated, and ocean circulations develop in the ocean from equator to pole, and a lot of energy is sent to the pole, and the reverse way happens. So this is called global ocean conveyor belt. It goes here, it goes here. goes there, and then the reverse way some cold water will come, and then again. So this is one of the major energy transport reason for the total energy for the climate, that, and a lot of energy is transported by the ocean conveyor belt. Anything happens with the ocean conveyor belt, that will definitely reduce the heat, exchange of the energy, and definitely the climatic variability will definitely occur. Now this can come, one of the reasons that this conveyor belt can be disposed is melting of the glacier. Antarctic, Arctic, these glaciers melting and total thing coming into the sea, that will raise that the cold water will come, the water will increase, and the ocean will become cold. The conveyor belt may decrease, and the energy transport will not. So this is sort of the feedback of the climate change. If climate change, that is what we see these days, that if climate change takes place, glaciers will melt, and those things will happen. So the fresh water mixes with the sea, and then can disturb the total conveyor belt. That is what I had said earlier, and it may disturb. And calculation of this would be definitely better, but oceanographers have the tools to calculate the effect of this. Solar output. Solar output also changes, and the change is in the range of 0.1 to 0.2%. And this is because of variety of things happening within the sun. And there is one solar cycle called solar cycle. The solar cycle is around 22-year cycle. A lot of magnetic storms happen there, and these magnetic storms happen, and they will come to the, and the polarity of the sun changes from the north to south, the positive to negative, negative to positive, it changes, and in that process a lot of energy is thrown out of the sun, and the earth atmosphere system receives that. So that may also cause. Now here we come, these days climatic variability causes, this may be one of the candidates. Ocean conveyor belt is one of the candidates. These in the these 10-20 year cycle, they can create the variability. They may be one of the causes of that. It has been suggested, it has been tried in few of the atmospheric climatic variables. For example, we have the sunspot cycle, sunspot cycle. Great phenomenon available. They have tried to link with the climatic variability with a little bit of success, but this is one of the parameters that always gets included when we start studying the variability. Okay, this is a sunspot cycle, that a good record of that has been obtained. Sunspot cycles have the 11-year cycle, and this 11 cycle here embedded, and certain things, these variabilities have been observed according to sunspot. But these are certain things, but there could be certain things that internal climate system, Earth, ocean, atmosphere system itself may generate certain variability, and these are the realities, and that is what is happening. And present day variabilities, these are definitely giving inputs to that. One of the things, these complex internal, what will happen, atmosphere interacts with the land, ocean, atmosphere, land interaction produces certain variabilities, and over the different time scale. Well known of these variabilities around the globe, one is the El Nino Southern Oscillation. El Nino, this is one climatic event that everybody talks about. This is one, and this is related to Southern Oscillation. In particularly this Asia Pacific countries, if most of the people are attending here, so they have more concern of the El Nino Southern. But like this, there are certain other oscillations, like called Atlantic, North Atlantic Oscillation. It affects the North Europe, American continent. North Pacific Oscillation, this also affects the European and American continent. Pacific decadal, these are the large decadal oscillations occurring in the data they have been delineated. So what these are different variabilities. In the presently one can even see their impact. So we'll take only one, and that is what is affecting over the variability in the Asia Pacific region. Of course, it affects the total globe, but here the impact has been shown, and that is the El Nino Southern Oscillation. This is one of the things, and it is happening because of the interaction between the climate system. The atmosphere, ocean, land, they interact in a different way, and then they produce this. So what is El Nino? This is a very common word. This is a newspaper term, but still let's see what it is. El Nino, this is the Pacific region, this is the American region, Peru coast, and this part will be our Asia Pacific region here. Now this region, sometime during the winter, gets heated up by 2 to 6, good number, 1 degree, 2 degree. 1 degree rise in sea surface temperature is a big amount. You remember yesterday I said that this ocean is one which have the largest heat capacity. So it produces under so much of ocean, these temperatures rise along the Peru coast here, and that we call as the El Nino appearing here. And this creates havoc throughout the globe. And this is the actual SST, observed sea surface temperature, Pacific region, American coast, South American coast, and this is the temperature changing. You could see, if you are able to see such a number, it can be 1. And depending on how much this temperature has changed, the anomaly, the severity of the El Nino will. Well, why does this El Nino become so important? See this. When El Nino happens, before El Nino, it starts like this. In January 97, there was a big El Nino in the big El Nino event there. So it starts from the bottom of the sea. This red means the sea surface temperature started increasing. Then the normal, these are the anomalies plotted. So this is the normal period, and this is happening in the normal. Then low El Nino happening. But when El Nino happens, this is the you can see the gaps, and you can see that how the high sea surface temperature zone shifts. Whole area, earlier it was a small area, now it is such a big area involved with the high sea surface temperature. What will happen with the high sea surface temperature? Earlier evaporation taking place here. Now whole Pacific, huge basin, this thing may come, and if the precipitation, this is coming, this gets, it will go up. It goes up, means low pressure gets developed, and the total global circulation gets developed, and that is what happens in the sea. So this is what is shown, and this is also linked with the only this type of behavior. See, El Nino, I can't go much detail, happens every few years it may happen, and it may last 2 to 3 years. Again, climate variability will always for 2 to 3 years, 8 to 10 years it will occur. So it does occur. It earlier happens in the southern hemisphere pressures also, Australian pressure and South American pressure, and El Nino in this, they are some sort of linked one, and the combined activity is called El Nino Southern Oscillation. So they oscillate like this. This is sea surface temperature is plotted here, and sea surface temperature is the more sea surface temperature is 3 degrees, 1 degree, and here it is below the normal. These things. So this is called, this is the strong El Nino year. These are the El Nino years. These are the La Nina. La Nina is just opposite of the El Nino. Now what this will happen, and this is also called Southern Oscillation, and the periodicity of both the Southern Oscillation and El Nino, SST and the pressure tissue, they are more or less. So this all event has been investigated, and the variability there, see the variability coming there 2 to 3 years. That is one of the global variability that is. So if any climatic data that is available, one of the things that may occur is because of the El Nino. Definitely because of the El Nino, there will be a certain variability coming into that. Okay. I thought I had one more slide, but I don't have. So that is what it will do. And let me go, because this I have introduced the subject. What it will do is the whole region. Earlier the low pressure area was here because SST is high and the heated air temperatures are high. the air will move up. And now here whole region is low pressure area. So whole atmosphere goes upwards. So because of that, total global circulation shifts, and that is what affects the all part of the globe, and that may affect even our Asian continent and the Asia Pacific region, and it affects, it impacts, and the periodicity of that, variability of that will come to the variability of the, if we are considering the rainfall, it will be affecting the rainfall in a variety of ways that will be affected. So I think I will not go much more than that. So that is one. So so if you want to see the certain natural causes for the climatic variability, we have the long ones are always there. So you think about that, Milankovitch cycle. Then we have sun's activity. Then we have internal dynamics. Then we have again natural activity, but periodicity is absolutely not known. These volcanoes. Volcanoes affect significantly the atmosphere. And this is one of the well-known volcano we call Mount Pinatubo of Philippines of 1991. It has affected the climate for certain. Now, why this will change? Then the volcano will, because of the volcano, I think I have slide here. The sun radiation comes here. As I said, the sun's radiation is the most important for climate. Or let us go from the bottom. Explosive volcanic eruption occurs, lot of dust will be in the atmosphere. Sulfur dioxide is added to the atmosphere. Because of the sulfur dioxide, sulfuric acid is produced. Because of the sulfuric, it gets attached to the aerosol. Huge clouds will be there. So because of that, not only the atmospheric dust thrown by the volcano, but there are many, and which also gives us the aerosol, variety of the things. So huge obstruction in the atmosphere will be there. Sun's radiation will reach less, but major part of that gets more reflected, and the cooling may occur. So this is in a different way. This will also give us certain change in the climate variable. So volcanic effect, but problem with the volcanic effects is that they will occur aperiodically. So when they occur, we don't know, but they are natural causes. They will definitely change it. So around that time, they will impact it, and the variability will be obtained along with them. So these are the volcanic eruptions. So that was the thing that now let us see the actual change that is occurring now. I did tell you about the natural causes, but now let us go to the actual thing that is happening around the time now when we are living now, and this is what is of concern. In past 140 years, global change data, temperature data. Again now, this will come to the global warming. That is what we call. So this is all increasing. Warmed 1 degree Fahrenheit. The slide comes from. So this is Fahrenheit 120 years. Now, what could be the cause of this? That is, and definitely the upward trend that is coming here, that cannot be coming from the natural. Some estimate has been made, and small number of this increase could be certain attributed to the natural one, but the natural causes are not able to explain that. And that is where our next thing comes, is the greenhouse effect. That was what was. And greenhouse effect, now I will have to go slightly faster to explain that. Okay, I think I can do it. See, crux of the greenhouse effect is our sun's radiation coming to the earth, and there is always a balance at the top of the atmosphere. Whatever radiation comes from the sun, it gets absorbed in the atmosphere, it gets directed to the earth. Earth has certain temperature, and according to Planck's law, earth also emits radiation because it has certain temperature. Atmosphere also emits radiation. These are called long wave radiation because temperature is less. Radiation emitted by these are having long waves. then the solar radiation, which are called short wave radiation. So ultimately, there is so this Earth atmosphere system emits radiation, solar radiation comes to the system. Ultimately, there is a balance at the top of the atmosphere. The net balance is zero, so that the equilibrium state is here. So this is what is shown here. Quickly also, incoming solar radiation 342 watts per meter square. Part of this is reflected by clouds and aerosols. Part of this is absorbed by the surfaces. Okay, and part of this which is absorbed by the Earth's surface will also go back, and the total atmosphere and clouds and aerosol and Earth dispersed part is radiated. So this will be to the top of the atmosphere. So this is the sun's radiation. The outgoing long wave radiation, this goes directly emitted by the Earth atmosphere system, emitted 235 watt per meter square, and different things are happening here. Now, if the clouds are there, they will not allow the long wave radiation to pass. They will absorb that. That's the property of the system. And that is what we have, the greenhouse effect. If we have certain system, the clouds there or certain greenhouse gases, they will absorb the whatever is emitted from here, it will not go. It will not go up. What will happen? That will be trapped in the atmosphere, and that trapping will cause the temperatures to increase, and that is what is the greenhouse effect. And this greenhouse, because of that, temperature changes, global temperature will change, and that is what is happening. Now there are variety of greenhouse gases. Atmosphere acts as blanket. Greenhouse gases, carbon dioxide, methane, nitrous oxide, they are warming agents, and this I have already, this is, you can compare with the greenhouse with our Earth atmosphere system. So this is what has happened now. Over the years, these greenhouse gases have not increased. They remained up to this level. Okay, and if you see the recent one, everything has steadily gone up. And this is what is causing the concern. And this is what is changing the climate. And this, though all these greenhouse gases increasing, they are mostly because of the industrial revolution, because of the emissions made by certain carbon dioxide, methane, nitrous oxide, and because of the pollution, because of the vehicular transport, the variety of things happening, and they are changing, and they are definitely, so greenhouse effect is significantly increased, and they are increasing the climate change. So that these rate changes can definitely be attributed to these. So now to reduce them, for example, this carbon dioxide, there is a place the carbon dioxide has been measured steadily increasing, the total carbon dioxide increasing. So that's not a good thing. That naturally it doesn't happen. It does happen because of the man-made changes, and this is how it is happening. Now, a lot of global effort is going on there to reduce this man-made changes, and there enters the politics, because all these industries, they will be affected. If I say stop this, the industry will be affected, economy will be affected. So then somebody says, no, this is that Milankovitch cycle is coming. I can explain on that. Somebody will say this, somebody will say that. That is how the whole politics comes. We don't go into that, but it does change that this is changing. Okay, so glaciers and polar and ice melt, they will melt slow. Now what will happen because of this change? 1 degree global change, 1 degree is a tremendous amount. The total globe 1 degree change. Regional climate, it may not affect that significantly, but the global one is, so it will change. So what it does, glaciers will melt, sea level will rise. That's the consequence of this. The sea level from the tide gauges they have been measured. They may not be that accurate here, but these are very accurate measurements here available now, and it is constantly sea level is increasing. Now sea level will increase because of the glacier melt. Not only glacier melt, it will be because of the temperature change, the ocean also expands. Because the more temperature you are putting in, that also expands. So with that, sea level changes, and sea level change had great consequence for the many countries which are low lying, like our neighbor country Maldives. it's one of the most vulnerable area for the sea level changes. So sea level changes are now, satellites are giving very improved, very accurate sea level changes. So this is the final example we have seen here, sea level rise over last century. This is very accurate measurement that, and definitely this is increasing. From earlier information from tide gauge, over 100 years, global sea has risen 10 to 25 centimeter. 2 to centimeter, now out of 10 to 25 centimeter, 2 to centimeter due to thermal expansion, 2 to 5 due to glacier, but other things not known. Now what we do? Now tomorrow we'll have the prediction models. In the prediction model, we can predict the sea level. But it requires a lot of input. So variety of inputs will be there, and everybody says it will change by this, by so many years, it will, the sea level will change. So that is again an uncertain thing and occurring in a variety of ways and gives uncertainty and will definitely it's of concern. Okay, so the sea level definitely changes. How much, that is uncertain, and this man-made effect has definitely the consequences. I think I have already told you that. Heavier curling, this I need not. But the one worst thing that happens is changes in where we can farm. The agriculture pattern will change because of the change. Amount of drought may be increasing. The extreme events that now sometimes are being seen, whether they are reflective of this warming, those things can come up. So they may come up. So severe may be more common. Ecosystems are changing, and because of the, as temperature warms, species may migrate from one place. So that is coming, and that is generating a new discipline, and that we have to investigate. We have to be sure of that, how much it can affect, how much it can go, how much it is increasing. So we get a actual realistic value of that. So this is in short the climate change that is taking place naturally as well as the man-made, and the consequences of the climate change, and we have to be alert enough so that we know. And a lot of activity is going on around the world about how to contain this man-made change, and some efforts have fructified, some efforts have not fructified. But what I would say, it is a slow poisoning. Whether it will ultimately do what, but slow poisoning, once it is one way, reversible, it becomes irreversible, and then the repair cannot be done. That is another. Now here comes the satellite, because in all these climate predictions, most of the things that is causing the concern, the inaccuracy comes because of the clouds and the oceanic response, and satellites play a big role. Again, I am an advertiser of my brand. So this many activities, international satellite projects for the cloud climatology, again they has been taken, but there are variety other things. The satellites are now giving more, in fact the satellites are giving information about the climate change parameters itself. A lot of the stratospheric temperatures and other things, they have been very, because they will be very well continuous information available that is there, and we hope to see much more from the satellite. In fact, a specific satellite for the climate related, like a CloudSat was recently launched. It gave some data, but besides that, our own country, my country, we launched one satellite, Megatropic. The purpose was to get more and more climatic information. The satellites definitely in a day will help us in getting the more information on the climate change. And so thank you very much. This I again